Welcome to the HC Commodities Podcast, a podcast dedicated to the commodities sector and the people within it. I'm your host, Paul Chapman. This podcast is produced by HC Group, a global search firm dedicated to the commodities sector. Today we're joined by award-winning journalist and author Vince Beiser. Vince was previously on the show to discuss his book, The World in a Grain, all about sand, and I recommend listeners to go back and listen to that if you missed it. But today we're discussing his new book, just published by Penguin Random House, called Power Metal, The Race for the Resources That Will Shape the Future. Vince puts his investigative journalist skills in action to trace and track how the critical metals of the energy transition are produced, the impacts of that production, the circular economy, and also some of the solutions around how we achieve the energy transition as efficiently and as least damaging as possible. As always, you can support the show by leaving a positive review on the platform you're listening on. And as always, I hope you enjoy the episode. Vince, welcome back to the show.
Well, thanks for having me, Paul. It's great to be here again.
So we're talking about your new book, just published, Power Metal, The Race for the Resources That Shape the Future, published by Penguin. And I've finished it. I enjoyed it. It's sort of slightly terrifying. And in the story, I guess, that in some ways we've covered in previous episodes with previous guests, but I think you bring new light to it and also very much sort of the human stories behind it. Before we sort of dig into the book itself, can you just, I guess, how come this topic attracted you and what was the scope you were aiming for?
Yeah, well, I sort of stumbled into it. I mean, as I say in the book, basically what happened was way back in 2018, I bought my first all-electric car. And for a minute there, I felt all virtuous and all good about myself. Like, yay, look at me. I'm doing my bit to save the planet. But then, because I'm a journalist and because of, like my experience with the sand book, I've really been doing a lot of writing about sort of the story behind all of our lives. What makes, what are the raw materials and the supply chains that make our modern lives possible? So I started to wonder, well, what goes into this car? How was this car actually built? What, the battery, the motor, where did all this stuff for that come from? So I started looking into all of that, and to my horror, discovered that in fact, that the metals that make up the battery, that make up the motor, that make up the wiring of that car, the supply chains for them involve rainforests being cut to the ground in Indonesia, involve kids being put to work in mines in Congo, involve unique ecosystems in Chile being put at risk, all this terrible stuff that I really did not know about. And I figured, this is a really important story that more people need to know about. And not only that, but like the second step was, okay, this is a problem. There are all these problems in the supply chains, in the ways that we are getting the metals that we need. But we do need these metals. We do need to switch over to electric vehicles. We do need to switch over to renewable energy. So I didn't want to just do a book that was, pointing out the problems. That was just like, oh my God, this is terrible. Look at all these bad things we're doing, like we journalists often do. I really wanted to look at solutions, because we have to make this transition. So how can we do it better? How can we pull off the energy transition without trashing the planet in the process? So that's I was really aiming for that whole picture with the book. So the first half of the book is mostly problems. Here's all the damage that we're doing. And then the second half of the book is really trying to take a look at, okay, but we need these technologies, we need these metals. What are some better ways that we can get them? So that's the goal.
Let's now turn, I guess, to the first part of the book, which is really kind of the dark side of this insatiable consumption of materials for the electronics age. Can we sort of, we've covered before how essentially, these are quite dirty processes, whether it's, across really the critical metals. And as a result, a lot of that was outsourced eastwards. And in the process over time, eastwards, i.e. particularly China, captured the processing capabilities. Can you give us, sort of Mountain Pass in some ways is emblematic of that transition and the challenges today. Can you sort of perhaps, I guess, using that story, which you cover in detail, tell us about sort of some of the ramifications of mining these critical metals and how indeed actually these processes, the processing ended up in Asia?
Yeah, absolutely. I mean, so Mountain Pass mine was the biggest rare earths mine in the world for a long time. It's located in Southern California, and it's just a great example of what happened with not only mining but so many heavy industries here in the United States. Basically, so we had this mine that was this enormous supplier, but it came with a lot of environmental problems. There were some spills of polluted water, like huge amounts of toxic water got accidentally spilled out into the desert nearby. There was a lot of uproar around that, and the mine got saddled with so many obligations, with so much, it was in the red basically because of its environmental footprint, and it wound up shutting down. And the company that owned it essentially sold the technology to companies in China. So China happily stepped in as the US got out of the rare earths mining business. China happily picked up the slack. They have enormous reserves of rare earths in a place called Bayan Obo, which is up near Inner Mongolia. So in very short order, China had established itself as far and away the world's biggest rare earth supplier. In fact, it supplied something like 90% of all the world's rare earths. So one result of that is this region around Bayan Obo is one of the most polluted areas on the planet. It's just, pocked with these enormous lakes of toxic waste. There's terrible cancer and other diseases that are affecting the people who live nearby. It's just an absolute environmental hellscape. The other thing is that, as I say, China completely cemented dominance of this really crucial industry to the point where they really have the world by the throat. So we saw that they can actually use this leverage, that they're quite willing to use this leverage back in 2010. So in 2010, China and Japan got into a kind of a maritime dispute, a little diplomatic dispute over some disputed islands. And to punish Japan, China cut off all exports of rare earths. Among other things, rare earths are absolutely critical for consumer electronics. Obviously, Japan's got a huge consumer electronics industry. All of a sudden, China has cut off their supplies of rare earths. It sent shockwaves all around the world. And it was really one of the first things that made Western governments, Western corporate leaders kind of sit up and take notice and realize, oh my God, we have literally just handed China this enormous leverage over the rest of us. We've given them this incredible weapon should they ever choose to use it. And that's one of the big concerns about this new era that we're entering into. Not only the environmental damage and the social damage that comes with digging up all these minerals, but the way that it gives tremendous power to China.
So much so that MP Materials, that mine has restarted, but actually they're exporting the rare earths back to China for processing, because also lots of those capabilities that are critical for both the energy transition but also, defense and so forth have been lost.
Exactly. That's exactly right. So MP Materials started back up a few years ago. Some venture capitalists basically bought it, started it up, and it's doing pretty well in terms of production. They are digging a lot of rare earths out of the ground, about 15% of the whole world's production of raw rare earths. But there is nowhere in the United States that's capable of processing the ore they pull out into actual usable rare earths. So it all goes straight back to China. And this is the thing that's really important to understand is China dominates the supply chains of these critical metals right the way along, from when they're pulled out of the earth to when that rock and ore is refined and converted into metals, to taking those metals and using them to build wind turbines, solar panels, electric car batteries, all the rest of it. At every stage of that process, for almost all these metals, China dominates it.
Yeah, but and this comes back to your sort of starting comment about sort of your car, your EV, which is, of course, most of these critical metals, many of them, at least the where they're currently mined, sit in the developing world or they sit in China, where there are much fewer controls on environmental safeguards and obligations. And you have, as you said, this hellscape associated with not only just the mining but also with the processing. And this is true right across the board, right? You spend a good amount of time in the book talking about nickel and hexavalent chromium, and the fact that Indonesia has these nickel laterides which are much harder to process than what Russia has. And can you just give us some sense of what's going on in Indonesia with nickel?
Sure. So yeah, I mean, this is definitely one of the biggest stories of it all. So nickel we need for batteries primarily. All those lithium-ion batteries in our phones. Basically, all digital electronics run on lithium-ion batteries. So does your cordless drill, your electric toothbrush, and also the overwhelming majority of electric vehicles have these lithium-ion batteries that need nickel. And Indonesia has enormous amounts of nickel, and they've been really rushing to capitalize it. And they've actually made themselves, just in the last 10 years or so, they've taken front spot as the world's number one nickel producer. And that has meant cutting rainforests, thousands and thousands of acres of rainforest to the ground in order to get at the nickel that's underneath them, which is bad enough from an environmental standpoint. But also Indonesia wants to move up the value chain. They don't want to just export the raw materials. So they're also really building up their refining capacity. They're building nickel refineries at an incredible pace. I mean, tens of billions of dollars of investment. And those things too are enormously refining. It's a really energy, especially the type of nickel that they have, as you say, requires a lot of refining, a lot of processing to bring it up to the level of purity that you need for batteries. So those refineries are just spewing out pollution into the air, dumping toxic waste into the waterways and even into the ocean. It's causing a massive environmental damage. And P.S., it also seems like their labor safety standards are incredibly lax, because dozens and dozens of workers have died in industrial accidents in these plants in the last couple of years. I mean, one of the people I talk about in the book was this young woman named Nirwana Sele, who was a TikTok influencer. She's like in her early 20s, and she worked inside of a nickel refinery, operating heavy equipment, moving molten nickel from here and there. And she built up quite a big TikTok following by posting videos of herself sitting atop these huge cranes, singing pop songs, lip syncing along to pop songs. Well, just about 2 years ago now, while she was sitting up in her workspace, there was a gas leak inside the plant, triggered a huge fire, and she and one of her coworkers burned to death.
Tragic. And I guess that's part of the element of this book, and your books in general, is kind of the interviews that you do, your the sort of the human element to this, and bringing some of it really home. There's also kind of, and you allude to it in the book, there is also a bit of a challenge there as well, because, full pelt nickel, but already we're seeing technological change, technological volatility that means that there might not be as much nickel needed in the lithium-ion battery of the future, LFPs and so forth. So there's also these big bets being made and kind of breakneck races to exploit resources. But, there's no guarantee that the chemistry today will be the same as tomorrow. And that's a very true story for nickel and cobalt.
Yeah, that's absolutely true. Actually, if I could just say one more thing about nickel today, I just want to talk about Russia for a second. Russia is still the world's number one supplier of high-grade nickel, the best stuff to put in batteries. And it really struck me. I started working on this book, or I was, looking into nickel in late 2022, almost a year after Russia had invaded Ukraine. And there was, despite all of the hullabaloo about economic sanctions, and we have to punish Russia and we have to cut them off, Russian nickel and copper was not subject to any sanctions until, at least from the US, until just a few months ago. So and of course, Russia continues to export nickel around the world. So there's a very real way in which nickel, the nickel that goes into our batteries and so on, helped fund the invasion of Ukraine.
Yeah, we had Stephanie Baker on recently on her book, Punishing Putin, talking about sort of the very deliberate excise of commodities from many of these sanctions because, the spice must flow, right? And in many ways, in this new energy transition world, the US is far more vulnerable than it is in a hydrocarbon world, which is the backdrop to many of these stories. There's so much in this section of the book. One other bit I just want to touch on, because I think it would be fascinating to our listeners, is you go quite in depth on deep sea mining and talking about the metals company and this sort of idea that these metallic nodules on the sea floor, and they're rich in all this stuff that we need, and hey, look, this isn't going to do any damage to the environment, it's all hidden away. And can you unpack that story a little, and not just directionally, but kind of where it is at today?
Sure. So in a nutshell, there are billions of these little rocks, these sort of fist-sized rocks called polymetallic nodules on the bottom of the Pacific Ocean and in a bunch of other places around the world's oceans. And they are indeed jam-packed with nickel, cobalt, copper, manganese, a bunch of the stuff that we need for the energy transition. So no question they're there. No question there's, countless billions of dollars worth of this stuff. The question is, should we strip mine the ocean floor to get them? And, the answer, basically, if you talk to any scientist, any marine researcher that isn't directly connected with the would-be sea mining industry, they will tell you, no, we shouldn't, or at the very least, we should not do this for many years until we've done enough research to be able to do it safely. Because if we wreck the oceans, it's all over for all of us, right? Human life depends on healthy oceans. And let's not forget, the oceans are already under serious stress from climate change, from overfishing and pollution. So the idea that, we're going to, on top of all those stressors, we should start strip mining the ocean floor, to me is a bit crazy. But of course, there are a bunch of companies and a bunch of national governments that are absolutely licking their chops, just salivating over the idea of all the money that could be made if we start pulling these things up to the surface. So the only thing that's stopping them at this point is international law. There's a sort of United Nations body that has the job of basically saying yes or no to deep sea mining. So far, the answer is no. Nobody is allowed under international law to start full-scale deep sea mining. However, there's a lot of pressure to change that. And there's one company in particular that I talk a lot about in the book, the metals company, that is really pushing hard to get permission to start deep sea mining. And it's been this kind of ongoing dance back and forth at the International Seabed Authority, which is the UN agency that gets to give the thumbs up or thumbs down. They were hoping to start, the metals company originally said they expected to start mining this year, 2024. Now they've pushed that back to next year. And it's really an open question. I mean, the ISA meets every few months, and this is topic number one on their agenda, and they keep haggling it back and forth. So far, they have still not issued permits for actual mining. There have been a lot of pilot projects. So the metals company and others have sent giant robots to the bottom of the ocean and dug up a bunch of these metals and brought them back to the surface. So they've proved it can be done. But so far, they're not allowed to. But that could very well change in the next year or two.
Yeah, international law seems to be getting more and more fragile, right? So watch that space. Okay, so then, and there's so much in there. And again, I just encourage listeners to get the book. Then you move on to kind of, I guess, the umbrella term in your book is the reverse supply chain, which is all things really recycling and indeed reusing. And this concept being actually, whilst you state in the book, we're always going to need more of this stuff to achieve the energy transition. There's obviously quite a lot already sitting around in rubble and in landfill and so forth. And we can all imagine our top drawers in some part of the house that's got a whole bunch of old cell phones in it and so forth, rich in all of these rare metals, rich in things like gold and silver and so on. And you first, we'll come on to lithium batteries in a moment because they present real challenges. But there's sort of this mining the concrete jungle. And I guess in the sort of this idea that recycling is kind of clean and wonderful. I mean, recycling, as you retell it in your book, whether it's done by individual scavenging or on an industrial scale. I mean, this is dirty, complex, energy intensive, and dangerous, right?
Correct. On all counts. Now, that said, I don't want anybody to walk away from this podcast thinking, oh, recycling's terrible, I'm not going to recycle. No, recycling stuff, metals in particular, is better. It's easier on the planet than digging up fresh virgin materials to make new products. It is better, but it is a long way from harmless. Like, it has this wonderful image, and we all like to think, it makes us feel all good about ourselves when we're recycling. And again, to be clear, it is better than throwing a thing away, but it's also extremely energy intensive, very polluting, and it's often done on the backs of some of the poorest people in the world.
This is Katanga in Nigeria, where you go in the book. Can you just tell us about that and that supply chain and kind of the human, opportunity, but also toll that it represents?
Yeah, absolutely. So what happens, especially with things like consumer electronics, right? If you drop off an old phone or an old laptop to be recycled at your local Best Buy or whatever, your church or your community center has an e-waste recycling thing, there's a very good chance that what's going to happen to that thing is it's going to get passed from middleman to middleman to middleman and eventually put on a diesel burning cargo ship, container ship, and sent to somewhere like Lagos, Nigeria, where I did my reporting. And there's thousands of people who are sitting around all day, every day, cracking open old cell phones with hammers and screwdrivers, taking out the little bits of valuable metal, easily recycled metal, like the gold and the copper, stuff like that, selling that on to other recyclers, which means it's going to go back onto another diesel burning ship and sent off to China or to Belgium or somewhere like that. And the rest of it, the rest of the components, the plastic, the cables, all the rest of it is probably going to get dumped and or burned in just open burning pits. So I spent some time in this area called Katanga, where they just recycle basically everything. And there are these guys whose job is just to burn the old cables. So they're standing around these fires that are burning nothing but rubber and plastic all day long. You can imagine the kind of toxins that are in that smoke that's going up, getting into the lungs of everybody who lives nearby, adding to the terrible pollution in a place like Lagos. And then, and also there's toxins that seep down into the ground and even into the groundwater. So I went and spent some time, in this place in Lagos, and I was really amazed and incredibly impressed by the resourcefulness of the people doing this work. I mean, they're incredibly intrepid at getting every last bit of value out of this e-waste, but also the conditions that they're working in are absolutely horrific. And I really want to stress it's not only Lagos. This is happening in cities all over the developing world. In Delhi, in Jakarta, in Mexico City, you have the same kind of thing going on.
And part of that is there's no industrialization, for want of a better term, of recycling e-waste, right? There's a few plants, I think there's a Dutch plant and so forth that can actually take these circuit boards and they shred them and then they can get all the different composite materials. But there's no necessarily sort of organized supply chain really for doing this. It's currently very labor intensive, very human intensive, but also this kind of comes to, and we'll come on to it in a bit on the reuse side. Your laptop and your cell phone is not made to be deconstructed easily into its component parts for recycling.
Right. So first of all, your what you said is partly right. There is a supply chain for recycling e-waste. It's just a really faulty, janky, not very well built supply chain. So some stuff, especially if you live in a place like Western Europe, there's quite a well developed e-waste recycling system, and they have an enormous plant, like you said, in the Netherlands, run by a company called Umicore that recycles circuit boards and all the rest of it. Also, China does a lot of this kind of stuff. So some stuff ends up, getting properly recycled in places that have to live up to environmental standards and labor standards and all the rest of it. But a lot of it doesn't. And even worse than that, a lot of our e-waste just it never gets recycled at all. I mean, like you said, we've all got these junk drawers full of, old plugs and adapters and whatnot. And most of us just, because there isn't an easy way to recycle that stuff, the way that there is, you can't just put it out in front of your house the way that you can with bottles or paper. And so it just sits around. Or eventually, if you get tired of having it sit around, we just end up just throwing it away. Only about 1 out of every 6 mobile phones in the United States gets recycled at all. And so a lot of them just get thrown out, which is, not only terrible for the environment because these things can leach toxic chemicals, but it's also just an incredible waste of material. I mean, the UN reckons we are throwing out about $60 billion worth of critical metals every year just because the recycling supply chain doesn't work very well.
The energy and resources sector is experiencing unprecedented change. To help companies navigate this world and capture its opportunities, HC Group launched Enco Insights in 2023. Enco has rapidly become the leading global expert network dedicated to energy and resources. Enco Insights leverages HC Group's 20 years of connections and dedication to the sector to give clients the expertise they need to take decisions fast. Connect with Enco's experts for anything from a 1-hour insight call to a longer-term consulting project at encoinsights.com.
But also, I mean, and that's the flip side of this is the OEMs aren't making stuff that is easy to recycle, but they're also, as you point out in the book, talking about sort of the right to repair movement. Apple were deliberately slowing older models, right? Or your fridge. We've covered this before on the podcast. Your refrigerator is far more likely to break down because the motherboard fails than it is, the mechanics of the refrigeration fail. But irrespective, that motherboard is no longer made. You need to throw your fridge away, right? I mean, the Internet of Things is dramatically reducing the shelf life of things as well.
Yeah, absolutely. Absolutely. And part of that, like you say, is deliberate corporate strategy. That manufacturers deliberately make their products difficult to repair, and they don't allow the average consumer to get access to spare parts or the manuals that would explain how to repair stuff. And sometimes even the tools that you need them. Like, I'm talking to you on a MacBook. You can't open a MacBook with a regular screwdriver. You need a special Apple-specific 5-pointed screwdriver to open this thing up. And that's, of course, that's deliberate, right? Because Apple doesn't make any money if you fix your laptop yourself.
Yeah, you say in the book you have to rent the screwdriver for a day for more than it's worth to fix the laptop, right?
Yeah. I mean, now actually you can find those screwdrivers in other places. But yeah, just like 2 years ago, you had to rent this enormous full-scale kit from Apple to fix your iPhone. Now, all that said, this is a huge problem, but I will say this is one area where things are actually getting a little bit better, basically because of that right to repair movement that you mentioned. That's basically this sort of collection of activists and enthusiasts who've been pushing for laws for years to force manufacturers to make their stuff easier to repair. And after years and years of trying and failing and being fought tooth and nail by everyone from Apple to Samsung to Westinghouse, they actually started to finally notch up some victories. So Massachusetts, California, Colorado, they have actually passed some laws forcing manufacturers to basically to make their things easier to fix.
You've got to, when you step back though, that's going to be a small group of enthusiasts against a massive backdrop of wanting to have the new iPhone, right? And it seems to me, I guess let's touch on it now. It seems to me that a more effective marketplace, so pressure on OEMs to make products that, okay, fine, you might not be able to repair them, but actually they're more easily recyclable because stuff isn't all just hard packed glued in and so forth.
Right.
So some nod to that. But if there was the creation of a marketplace, a more institutionalized marketplace, with better feedback for us consumers to say, hey, I don't need to, my iPhone is worth $100 if I drop it in here. You know what I mean? You'd probably accelerate that whole process. Whereas at the moment, there's no real incentive structure or structured marketplace to extract the values from this enormous amount of e-waste.
Yeah, I agree. I mean, those things do exist. There are some of those incentives, like Apple will buy back some if you can trade in your old iPhone against a new iPhone, depending on what it is, blah, blah, but not nearly enough, not even remotely enough. I totally agree. But, we really could and should be doing much more of that. But it's tricky, right? Because at a certain point, what's good for the planet isn't necessarily good for a corporation's bottom line, right? There's a contradiction between the goal of sustainability on the one hand and profit on the other hand. Capitalism and sustainability there's a real conflict, because the best kind of product, sustainability wise, would be something that you buy once and it lasts you for your whole lifetime. But no company wants to sell you just one product and then write you off as a customer. They want you coming back again and again and again.
Yeah.
So I do think, but I really do think, if we're smart, we can shift, we can build up that kind of repair and reuse piece of the economy, which actually used to be a lot bigger not that long ago. There used to be, I forget the numbers, but the number of repair shops in the United States has plummeted just in my lifetime in the last, 50, 60 years. And that means that's a lot of jobs, right? Repair jobs are actually really good jobs to encourage. They can't be offshored. You don't necessarily need a college degree to do them. They can be really well paid. They are needed everywhere, right? Every town and city needs a fix-it guy. So if we could, come up with some incentives, some institutional supports for a more robust repair sector, I really think that's one of the things that's going to carry us through to the next era. Partly also because, let's face it, AI is going to destroy a lot of jobs in the coming years, and we got to come up with something to replace them. And I really think that fixing the stuff that already exists, that can be a very good job for the 21st century.
Yeah, we're about to lose, if EVs continue on their trajectory, certainly in certain parts of the world, they're much more mechanically simpler, but far more complex electronically to fix. So you're going to suddenly have cars defunct because the motherboard's gone, not just refrigerators. But let's just move on to, so I kind of found this fascinating, right? So lithium-ion batteries, have a real challenge when it comes to recycling because they tend to blow up now and again.
Yes.
You've got CATL in China that does a lot of this, but one of the big challenges is actually you can't ship this stuff. So just tell us, these pilot projects that look quite good on the surface of shipping lithium-ion batteries over to I think it was to Europe, but in the end they were transported in barrels of sand. Yeah, and and the easiest way to get this stuff over the seas is to mislabel it.
Yep. So indeed, the big problem with lithium-ion batteries, like you said, they tend to explode. If you puncture them, if you squash them, they can burst into flame. And there's, if you just Google lithium-ion battery fire, you will see this is happening constantly all over the world. People are, landfills are catching fire, garbage trucks are catching fire, people's houses are catching fire, people are dying in these fires. It's a really big problem. So, of course, no shipping company wants to transport these things. So one of the story that I tell in the book is about this very well-intentioned Dutch startup called Closing the Loop. And their idea is, that there's all these cell phones all over Africa that are being recycled in that way that I just talked about, in these ways that are, really damaging and destructive. So their idea is let's bring those African cell phones back to Europe where they can be properly recycled, where they can be recycled, in an environmentally responsible way. So nice idea, but who's going to pay for it? So their model is they're getting European companies like Samsung and other places to basically pay them. Like when you buy a new iPhone, give us a couple of bucks and we will recycle an African iPhone properly. Okay, that's the idea. In practice, it turns out to be really difficult. And one of the biggest problems is the batteries. So it's easy enough to round up a bunch of cell phones and ship them to Europe. But the batteries, what are you going to do with the batteries? Nobody wants to take them. So the workaround they had to come up with was, as you said, they pack all the batteries. They have to separate all the batteries from all the phones and then pack them in sand, in barrels of sand. So on top of all their other costs, now they're having to ship hundreds and hundreds of pounds of worthless sand. So they pulled it off. They've done this a couple of times. They've run a couple of pilot projects and brought several tons of dead iPhones from Nigeria and other countries back to Europe, where they were properly and responsibly recycled. But the whole process was a complete money loser, because by the time you add in all the costs of shipping those phones, separating out the batteries, packing them in sand, paying for the extra shipping costs caused by the sand, and P.S., all the administrative costs caused by well-intentioned but sort of now somewhat backfiring things like the Basel Convention that restricts the transport of e-waste. You add up all those costs, it's just crazy expensive.
Yeah, which is a real shame, because we've had Kling Systems on this podcast before who are trying to create a secondary market for batteries. One challenge is that the EU's now got its Battery Act, which means they want people to track usage and all that, provenance and all that kind of stuff, which adds a layer of complexity. But the other is, of course, we're about to hit a mountain of battery waste from the first generation of EVs, cycling over. The ideal scenario there is that an EV battery is really, it's top of its game. You can take that battery and put it into, a forklift truck or, a golf cart or whatever it might be. Mm-hmm. But if you can't ship these things globally, mm-hmm. they're going to stay in situ and they're probably going to end up in a landfill, right? So it's kind of how can we tackle that piece of the supply chain as well? So it's, we're reusing these batteries just in different capabilities rather than just pulling them apart and so on.
Yeah, no, I think the reuse piece of it can be really important as well. I went and visited this startup in California that's taking old EV batteries and putting them together. So like pull 100 batteries out of used cars, stick them in a container, fill them up, and they've got a solar field right next to it. So their business model is they get solar power during the day when the sun is shining bright. They use them to fill up these EV batteries that are not, they're a little worn down, so they're not quite good enough to use in a car anymore, but they still hold, 70, 80% of their charge. So you put 100 of them together, you got a lot of power stored there. And then they sell that power back into the grid at night, which is kind of brilliant, right? So they're selling solar power, they're selling sunshine at night, which, I love the concept. And I do think there's a lot of potential in there, but indeed there's a lot of, the problems of the expense involved in shipping these things, in pulling them out of cars. There's a lot of hurdles to be overcome, but I do think that's one really promising area, because reusing a thing is always way more efficient than trying to recycle it, than trying to break it down and separate, bust out all the different pieces and components and then melt it all down. If you can just use the thing again for a different purpose, much, much, much more efficient.
Yeah, you spend the last few chapters of the book sort of on what the future might hold and how we can get there. And actually, as you start saying in your introduction, we've got to balance these mining and the inevitable consequences of that for the environment versus obviously tackling greenhouse gas emissions and moving through this energy transition. I guess I just want to ask, you've been writing this book for a couple of years. This is quite a fast-moving world, not only in technology, but also in policy. And obviously, it's quite a volatile time in policy, particularly around the energy transition. I guess what's changed since you writing it? What surprises have come up? Can you sort of give us sort of reflections now as it's about to be published?
Yeah, good question. So, if you'll forgive me some blatant self-promotion, I publish a newsletter every week. It's also called Power Metal. It's at powermetal.substack.com, which I started up basically for exactly that reason, because so much is changing in this whole space all the time. The technology, the financing, the awareness around it, everything. So that's my way of sort of trying to stay on top of things, of these developments as they're coming down the pike.
Yeah, I'm a grateful recipient of that. So yeah,
oh, great.
I recommend to other people.
Thank you. It's great to hear. So, the first thing that's on my mind right now, of course, is Donald Trump is on his way back into the White House, which could be really bad news for the energy transition, for all the stuff we've been talking about So under the Biden administration, one of the best things that they did was to pass the Inflation Reduction Act, right, which sent billions of dollars towards renewables and to recycling and to production of critical metals. All the stuff that we've been talking about. They recognized this is going to require serious government help to get this stuff up and running and up off the ground. And Trump doesn't believe in climate change. He said he'll repeal the Inflation Reduction Act. So it could be really a rocky road ahead.
Yeah, I was actually just in DC just before the election. And I guess there was a couple of interesting comments made. One was that, much of the grants in the IRA have already been dispersed. Mm-hmm. And it is law, so it would take Congress to truly unwind it, which now obviously is more feasible given that they control all parts of the legislature. But the other was that there's a certain amount of kind of reframing that goes on depending on who's in charge. So when the US military had, I think it was a renewables mandate, a clean energy mandate, they started putting solar power and renewable power on military sites. And when the previous Trump administration came in, those were just simply rebranded as resiliency projects. So
there you go.
There's it's quite a clever machine over there. So we'll see how it goes. But you're right. The IRA, which is has certainly put Europe on notice about the US is believed to compete in this sector. Would have a dramatic impact if that were unwound.
Yeah. So that's the bad news. The good news is, though, at the end of the day, for all its global influence and whatnot, the U.S. is actually a relatively small player when it comes to renewable energy industries. It's China that's by far the biggest producer of all this stuff, of all the metals, of all the solar panels, of all the wind turbines, of all the electric vehicles. And even if the United States is trying to keep out Chinese EVs, which they are trying mightily, the rest of the world is saying, man, you guys can make an EV for $10,000? We'll take it. Mexico's happy to import Chinese EVs. The rest of the world's happy to import Chinese EVs. So from a global perspective, I really think at the end of the day, if the U.S. ends up really turning its back on renewables and the energy transition, the people who are going to suffer the most is going to be America itself, because we're just going to get left behind. These are the technologies that are going to shape the, I call it the electro-digital age, because it's really going to be defined by electricity, by renewable powered electric everything and digital technology, the internet, electronics, all the rest of it. And, the U.S. is really way behind the curve when it comes to renewables and EVs, and we're losing what edge we had in terms of digital technology and AI and all the rest of it.
Yeah. There are some, there's also just fundamental economics, right, where you see places like Texas are out ahead on renewables, right, not because of subsidies, but because of purely the economics piece. So there is,
absolutely. And I feel like a lot of people have said that's the great hope for saving the IRAs, because most of those benefits are going to red states. Like you said, Texas is, the biggest renewable state in the country. And maybe that's part of it, right? Is like maybe we've got to sort of rebrand renewables. It's like people think of it as this crunchy, hippie, liberal, save the whales kind of thing. But, listen, if a state like Texas, is building more solar and wind than anywhere else, maybe we just need to rebrand it as, as American as oil drilling and pickup trucks.
Yeah. Yeah. It's quite it's what's fascinating about this story, and I think it's well known to us, and it's well known to many of the listeners, right, about the impact of these supply chains globally, and that they do come with a significant cost, and that the waste is mounting up, and as yet there aren't really solutions or market-based solutions that are driving better behaviors and so forth, particularly around recycling and so on. I'll leave listeners to get the book and read some of your conclusions. But I guess final sort of question is, did you end up in a deep state of depression or a sense of optimism at the end of this book? Because I know which I felt, but we discussed it. But yeah,
I end up, listen, I mean, there's a lot to be scared of. There's a lot that can, there's a lot that's already going wrong. There's much more that can go wrong. But no, one of the things that I really learned deeply in my research is how fast and how deeply the energy transition is already happening. We really kind of lose sight of it in North America because we're so far behind on it. But, China's, half of its grid runs on renewables now, and most new cars that are sold in China are electric cars. Europe is moving in the same direction, and solar power is absolutely exploding all over Africa, all across the developing world. Again, we don't see it here in the US because we're so wedded to our gas-powered cars and so resistant to change in a lot of ways. But the rest of the world is actually moving pretty quickly, and in places in the US too. So yeah, there's a lot of reasons for pessimism, but there's a lot of reasons to be optimistic. There are a lot of really promising developments that are happening. The energy transition is happening. It's not happening fast enough. It's not happening in enough places, but it is happening. I have no doubt that it will happen. And I think we're going to make it in a nutshell. And really our job is to let's make it as quickly and with as little pain as possible. But I do think we can make it.
Yeah. A key indicator of that, I think, this year was how surprised people were by gasoline consumption in China. And still somewhat wringing of hands about whether it's sort of changes in behavior or actually just how quickly EVs have penetrated. And we had Kingsmill Bond on a month or two ago talking about the energy transition as sort of it's unstoppable and it's exponential. So there's lots out there. Well, Vince, final question. What's next? So we've had you on for the world of grain, talking about sand. This is now the critical metals story. What's in the hopper?
I think, I'm not totally sure yet, but I think the next one's going to be about scavengers, about the millions of people all around the world who are making money off of what the rest of us are throwing away. And that's everything from, the waste pickers in the developing world to, industrial scale recyclers to this whole, the multi-billion-dollar industry, and it really is an industry of shops like places like the Salvation Army, the United Way, these places that turn over billions and billions of dollars of stuff that people literally give them for free. I think it's a really fascinating world, and it's really important. I mean, this is a really little noticed part of the world and part of the economy that's doing a huge amount to keep stuff out of landfills, to provide jobs, that has all kinds of benefits that most people never even think about.
Yeah, and you follow one or two in the book, and I'll encourage people to read it. Well, Vince, it's always a pleasure to have you on. I wish you great success with the book. We'll put links in the show notes to it. Well, when you've written it, we'll have to get you back on for the next one.
Sounds good to me.
Thank you for listening. To find out more about HC Group, our global offices, and our expertise in search within the commodities sector, please visit www.hcgroup.global.